Uh, each diagram first diagram, question 1. Copy and construct the image of each of the figure under central symmetry in the point O. Central symmetry, okay? So look at this, alright? What you do is you constantly try and pick any point you want, any corner, and you send it to the red dot, and you send it the same distance out the other side. Does everybody remember that? So look what happens. Okay, we'll do the green dots now. 2 across, 1 up. Everybody agreed? 2 across, 1 up. 1, 2, 3, 4, 5 across, 2 down. And then you go another 5 across, and you go 2 down. And then finally the last one is, that was 4 across, 2 down, so I made a mistake there. So 1, 2, 3, 4 across and 2 down. Everybody happy enough with that? So 4 across, 2 down. 1, 2, 3, 4, 2 down. Okay. Finally the last one, yeah? 5 across, 2 up. 5 across, 2 up. And guys, what results? What's the result of that then? Huh? A new triangle that's symmetrical in the central one. Yes? Oh yeah, just bring it up. So, let me show you how it links up. If you were to link this up, guys, it looks something like this. Everybody see what's going on now? See the way they link into each other via a straight line? Okay. Try another one. I'll try the one on the bottom left one. So this one is 2 to the right, which means that it's going to be 2 to the left. The next point is 3 across, 6 across, 7 across, 3 down. 7 to the left, 3 down. Okay, which would mean 1, 2, 3, 4, 5, 6, 7, 3 down. Okay, the next point after that, we'll do this point here, which is simply 5 across to get to 0, then another 5 across after that. And then the next point is what's going to be 7 across again? 7 across and 3 up. Do the same thing out the other side. 7 across, 3 up. Makes it that one. Whoa. 1, 2, 3. That's 6 across, 3 up. 7 across, 3 up will be there. Okay, do I have enough to make the image now? Everybody happy enough with that? They're handy enough, aren't they? Just counting blocks. Now, each diagram shows an object and its image. Copy the diagram. In each case, indicate the center of symmetry with a dot and label it 0. Okay. Now, if you imagine this point here and this point here, they're equivalent points, aren't they? Same level. How many blocks are they apart from each other? 2, 4, 6, 8. Would you be happy with that? What's the midpoint then? 4 blocks away. Okay? So therefore, 4 blocks away from here would be 1, 2, 3, 4. And that's your center, 0. If you aren't sure about that, you can do it like this. You can link them up like this, and they'll cross at the center. Okay. Try another one as an example. I could do the same one here. This, whoa, what'd you say? Yeah, you could just do one corner to one corner, the other corner to the other corner, and where it hits is the center. Make sense? And then same deal here. Any of them, in fact. Just any 2 points that are the same. Does that make sense? Okay. Same. Oh, explain why it's not the image. Why is question 1 not the image? Why are they not central symmetry of each other? Different distances from the center. 2 across, 1 across, 2 up, and the other one's 4 across, 2 up. They're not the same. They're the same. They're congruent triangles, but they're not central symmetry of each other. Okay. What about the next one? In green. 1 second. Make this a bit bigger. What about this one here? Huh? Well, it's not meant to be a mirror image. Would you agree that side's the same as that one? Really? What's different about them? 3 on the bottom, 3 on top. No, it's not meant to be a mirror image. Upside down. Look at the last ones. I'm pretty sure that one's upside down over here. See? And that one's upside down, and that's a central symmetry. We're not talking about mirror images here. We're talking about central symmetry. So what I'm going to do is what I've always done. I'm going to link them up together using the corners. I'm going to see what happens. Oh dear. Go again. There's only one reason. Misses the spot, doesn't it? There's nothing wrong with that iron, it's just the spot is slightly off. Is that alright? And the last one of them's a different shape to the other one. So if I was to try and link these up, it sort of works, doesn't it? But what's the difference? Different shapes. Okay? Different shapes. Different lengths. Now finally, question 7. PQRS is a square and SQRT is a parallelogram. Can everybody see that? Everybody can see it now anyway. Okay. Name 4 line segments equal in length to PS. Sorry? Okay, PQ. Anything else? QR. RS. Why is ST exactly the same length? It says SQRT is a parallelogram, correct? QR has to be the same length as ST. So ST is the other one. Okay. Under central symmetry in X, write down the image of the following. So central symmetry in the point X. This guy here. Okay, what's the image of R? R goes through X. R to P. Q to S. P turns to? Q turns to? RS. P turns to? X turns to? Stays the same. S turns to? Q. Or XQ. These are handy, aren't they? Central symmetry and Y. I think you're pretty good with them, aren't you? You're gonna find them easy enough, yeah? QRT? Yeah, I'll do 4, 5, and 6 if that's okay with you. Now, see PS, guys. Yeah? It wants me to do a translation. Does anybody remember what translation is? You have to go in that direction. It wants me to go in the direction Q to R. I have to go that distance to the right. If it said R to Q, I'd have to go that distance to the left. Does that make sense? Now, if I start off with P, where does that take me if I go the same distance to the left? Turns into S. And S will turn into T. ST. What's the image of P under axial symmetry in SR? Does anybody remember what axial symmetry is? Axial symmetry, anybody? It's like a reflection in the line. So, what does P turn into when it's reflected through that line? Oh, sorry. Yeah, what does P turn into? Yep. It's reflected all the way to the line and goes the same distance out the other side and turns into T. That's what axial symmetry does. So, oh jeez. T. Finally, the area of PSQ. What's PSQ? PSQ is worth 20. Yeah? Now, it wants me to find out what's the area of the parallelogram. Is everybody alright with that? Now, the parallelogram can be broken up into two sections. It can be broken up into a green section, and it can be broken up into a black section. What do you know about the green and the black section? They're both the same size as the red section. So they're both going to be, therefore, the size of the parallelogram. Parallelogram. 40 centimeters squared. Okay.